Today I'm going to be speaking to you about how alignment is performed within our 2D analysis software SameSpots. The first step in aligning your 2D gel and blot images within SameSpots is choosing a reference image. So the reference image can either be selected manually by using these buttons down here on the side next to the name of the gel or blot image that you've imported into the project file, or it can be selected automatically by default by the software. So as you can see, the SameSpots software has analyzed all of the images that I've brought into the project, and it's selected based on the intensity and the clarity of the spots within the image, which one would make the best reference image to align all of my other images to. So you can see in this instance, it's automatically selected file name gel4 internal standard CY2 stain. However, if I did want to override that, it would be as simple as clicking one of these other images to use as your reference image for alignment. Once you've selected your reference image, we then move forward into the alignment window. Now, SameSpots allows the user to perform an automatic alignment or a manual alignment, and our automatic alignment is based on pixel level alignment algorithms, which are a generation ahead of the warping algorithms employed by our competitors. What this means is our pixel level alignment algorithm can account for the geometric distortions inherent within the 2D gel electrophoresis technique. So just to explain what's going on here with these different windows, on the left-hand side is where you would perform manual alignment. So this window here is a zoomed in section of the whole image, as you can see, and is where you perform the manual alignment. And these two windows on the right-hand side are where you verify how accurate your alignment has been. So in the transition window, this is basically just a fade in and out of the two images, your reference image and your target image. Now, as you can see, the spots are jumping around, whereas if these images were in perfect alignment, they would appear to blink, and you'll see that once I perform an automatic alignment on this image. The checkerboard is a mosaic or made up of the two images, so every square is interspaced with a square from a different image. So it would go 1, 2, 1, 2, target reference, target reference. Now I'm just going to show you how to perform an automatic alignment and how much time that can save you in the lab. So when I click on automatic alignment, it gives me the option of selecting how many of my images I want to align to my reference image at once. I'll just select one for the purposes of this video, just because the more images you add, the longer it will take, but you'll see that it's a very quick process. So if I just click OK, so it will calculate now all of the vectors for alignment required for my target image to align with my reference image. So as you can see now, these blue circles are all of the automatic alignment vectors that have been inserted onto my image to align it with my reference image. So we can see here that within the space of approximately 10 seconds, it's inputted 911 vectors for alignment to match up my target image with my reference image. And you can see what I was talking about before on the transition window to check the alignment of your images. Instead of these spots moving around, they now appear to kind of blink or flash, which means that all of the spots are in the same position now on both images. And likewise with the checkerboard, you can see that despite there being one square taken from each image, they still align. Certainly on the edges of the squares, you can see that they align with the spots from each image. So this is how you would check that your image is aligned correctly. If a user does wish to perform their alignment manually, SameSpots has a lot of features to make that as quick and easy as possible as well. So the first feature is the ability to snap to spots on the reference image from your image that you're trying to align. So what I mean by that is, if you can see here, this spot obviously needs to be aligned on top of this spot relates to this spot, etc., etc. If I left click here to start my manual alignment and to add a vector for alignment, you can see that just by left clicking, not moving my mouse, SameSpots has automatically moved the image across to the spot that it believes that I want to align it with manually. If I release my left click, you can see that it's added a vector for me. So this vector describes the movement of this spot over here in this direction by this amount, by this intensity. And if I come across here and say, right, well, I want to align this spot with this spot on my reference image, again, simply left click and it will pull it across too. Now, SameSpots' pixel level alignment algorithm versus classic warping algorithms allow much better compensation for gel distortion. So gel distortion is a fact of life in doing 2D gel electrophoresis. You will experience different levels of distortion across your gel and across your images. So as you can see, this vector is moving this spot in this direction, whereas this spot, even though it's not located very far away from the previous spot, is moving in a slightly different direction. And this will be true for spots all over the image. They will all be moving in a slightly different direction by a slightly different amount. And this is where SameSpots really comes into its own, where you can have multiple different vectors for multiple different sections of your gel or blot images, and you can make sure that all of your spots are aligned uniquely with unique vectors for each single spot. Now, a question I've been asked before is how many vectors, if I'm doing this manually, how many vectors do I need to add to my image to ensure that I've got really rigorous alignment for my statistical testing further down the line? And the answer to that is, as many things in science, it depends. But that's why the transition and the checkerboard window are so important. They give the user the ability to check that their images are aligned and to check their alignment. So as I mentioned before, the transition window, the spots should not be moving, they should just be blinking. And in the checkerboard window, it shouldn't look like this broken mosaic, it should look like a solid image. And that's how you know that your two images are in alignment with each other. So as you can see, it's much quicker to use the automatic alignment tool to add in, around 900 different vectors to compensate for all of the distortions around the gel than it is to do it manually. But the option is still there for users if they prefer. Thanks for listening. And if you'd like any more information or you'd like to download a free demo copy of SameSpots to see how it works with your data in your lab, please check out the description links below.